Hey math kids, today we're going to use GeoGebra to convince ourselves that some theorems are true. So we're not necessarily proving these theorems are true, we're just going to look at them and convince ourselves that they're true for a specific case. So what you're going to do is you have to find some real world things that are triangles or parallel lines cut by a transversal, the different things. Now, parallelograms are actually really hard to find in real life. So for that one, I'm going to allow you to use just a diagram. And also the parallelograms, I think the parallelogram theorems are a little bit harder to understand. And so that's what I'm choosing to do in this video. But basically, you're going to go through the same process. So you're going to hit the plus sign, click image, find your image, upload it, move it to wherever you want. I don't like to put it right here. I like to put it kind of right here. Make it a little bit bigger if you want to. I guess that's fine. So we'll do it that way. Now, the first theorem says opposite sides of a parallelogram are congruent. So opposite sides would be like AB and DC or BC and AD. So what we're going to do is we're going to get our distance tool. Oh wait, first I'm going to define the polygon. So I'm going to go like this. And it's going to give us different letters, but that's okay. Okay. So I made this polygon. I'll click on this tool to make sure it lines up pretty close. Now, one thing to keep in mind when we're doing this is there's definitely potential for user error. So if your measurements are a tiny bit off, I would still accept them as being exactly true. Okay, so we have this. Now when I refer to points, I'm actually just going to refer to the actual given points, not the ones that GeoGebra generated for us. Just to, so this one is A, it's not C, just to be clear. Okay, now we want to measure a length, so we're measuring the opposite sides are congruent. So if I just measure all these sides, so D to E, or B to C. Okay, now we can see the opposite sides 5.71, 5.78. Now if I drew my polygon perfectly, these should be exactly the same. Obviously I made this one a little bit longer and this one a little bit shorter, but we can still see that they're roughly the same length. And then if we look at these opposite sides, they're basically 10.7. This one's a little bit smaller than that. Okay, the next theorem says opposite angles are congruent. So you may remember from previous video, but you go to angle, and then you need to measure in a clockwise fashion to get the interior angle. So if I want to measure this angle, I'm going to go A, D, E. Then I'm going to go D, C, B. Then I'm going to go C, B, A. And then B, A, C. All right, if we look at the opposite angles, once again, they're not perfectly congruent, but that's because of user error. That's because my polygon wasn't drawn perfectly. But we see it's about 70, about 70, about 109, about 109. Okay, so I think we can convince ourselves that this theorem is true. Opposite angles in a parallelogram are congruent. Okay, the next one is diagonals of a parallelogram bisect each other. Okay, so this one we have to do a couple things. We need to first draw the diagonals. Let's see, segment. Then, okay, so if we measure half of this and then we measure another half of that, actually let's put a point right here. There we go. So we'll get our distance. The halves should be the same if they really bisect each other. Okay, so the distance, this one, is 6.83. And so this one should be about the same. Yeah, so 6.83, 6.9, once again, user error is making that not perfect. Now if we go from here to here, it's about 5. If we go from here to here, we would expect about the same. So 5.11, 5.2, those are pretty close. And so these diagonals do bisect each other, because that means this piece and this piece are the same, and then this piece and this piece are the same. And then the last one is rectangles are parallelograms with congruent diagonals. So that one we would just need to draw an actual rectangle and show that their diagonals are congruent. I'll leave that up to you though. So we could just draw a rectangle, and then actually we can do that. So it wants us to draw a regular polygon. Oh, we don't actually. It's not going to be regular. Let's see. We can try to draw a rectangle. It's probably easier if you do it from a picture, though. So let's try this. Here, here. Okay. There's a rectangle, or at least hopefully that's a rectangle. Let's measure an angle. If it's 90 degrees, or at least close to 90 degrees, then, so once again, we go clockwise. Nice. I think that says 90. It's hard to see. Yep, all these are 90, so it really is a rectangle. So we're probably going to get better results with this. Now, if we draw the diagonals, now if those were drawn correctly, hopefully they were, they should be the same length. And so if we measure that distance, so that's 3.61, and 3.61. Now they kind of overlapped each other, but hopefully you saw that. They're both 3.61, so the diagonals are exactly the same. And the reason why we got better results on this is because I drew the rectangle and we verified that it was exactly a rectangle with 90-degree angles. But yeah, you would also need to prove that the opposite sides are congruent to make it a parallelogram, and also that the opposite angles are congruent, which we can see that. If you need additional help, please come to Math Lab. Until then, calculate.